Okay, so this is my 555, completely 555 based, functionally complete demo board. It builds all the boolean logic gates and a 2-bit ripple carry full adder together to show that just with 555, in this case, these are all TLC556s, so that way I could save on board space. You can just use 555 based or 556 or whatever to build logic gates. No other ICs required. So I've got all the demo outputs up at the top here, your adder outputs, NOR output, D flip-flop output, AND output, XOR output, NOT output. I have the inputs down here. So the adder operand A input is here, adder operand B input is here. The carry in for the two adders is here. My NOR inputs are here. D flip-flop along with the clock push button is here. AND inputs here, XOR inputs here, and the NOT input here. I've got my power in with reverse battery protection up here with just a power LED. And, well, what you see is what you get. Everything is fully labeled, including test points, so you could easily probe it. And, in fact, I already have, and have posted the actual propagation times of each of these gates. I measured them, and they're all fairly quick. Forgot to put in a couple of jumpers from testing. Okay. So yeah, you can fully test this and fully debug it, and this is just a proof of concept board to say, okay, can you make a Turing complete computer with just 556s or 555s? And I say yes, based upon all these results. So, for example, up is 1 for all these switches and down is 0. So for example, looking at the NOT output, we've got a 1 on the LED, and I flip it, goes out. And that NOT gate is just a single TLC 556. It could just be a single 555, given how simple a NOT gate is. XOR output, I've got 2 inputs here, and naturally Boolean logic holds. Turn on one, it turns on. Turn on the other and keep the other one off. Turns on the other, turn on both, goes out. Keep both off, goes out. AND output, this will only go high when both of these go high, so nothing on that one, nothing on that one, but if I turn both on, wham bam. And the AND gate is a single TLC 556. You need a 556 for this one, and you'll see in the schematic why. The XOR gate is 3 TLC 556s together, and these are just 3 separate NOR gates to build up a NOR gate version of an XOR gate. The DFF, so it's not a true edge-triggered DFF. It is a edge-latched DFF, or sorry, a level-latched DFF. So, for example, I'm flipping the D input here, and nothing's changing on the output, of course. So let me, since the output is 0, the Q output is 0, let me switch the D input to 1, and flip the clock, and bam, it latches in the value. And I can keep changing the switch back and forth on the D input, it will not change. But, and if I switch it down to 0 and click clock, it'll latch it in. But if I hold down clock, you'll see that it'll just take whatever. So I haven't quite figured out how to do a level sensitive clock. I think all it needs is just a single 555 at the front doing a one-shot timer to provide the clock signal out of this push button, and it should work just fine as a level triggered. But I did not implement that here. So that could be implemented by somebody else in the future. The NOR gate, of course, if I turn either on, the output goes 0. If I turn A input on, it goes 0. If I turn both on, still stays 0. Simple NOR logic. The adders, so this is a whole mess of things. The adders, each 1-bit full carry ripple adder requires 10 TLC 556s, specifically 556s. unless you want to go to 20 TLC555s to do the same effect. So got your sum outputs here, and you got your carry output. I was originally going to do a 4-bit full adder, but that would have just made this board massive and expensive, and I didn't want to do that. So let me go ahead. Right now the operand A and operand B are both 0, and the carry in is 0. Let me flip. Boop. Operand B, it's LSB goes 1, sum output goes 1, of course. If we flip the carry to 1, then of course the carry and operand B add together and just carries over to sum 1. Let me flip down carry input again. Flip on operand A, LSB to 1, and of course they add together naturally. Of course, if I keep all the LSBs 1 and push and carry, then it'll just add together, and you've got sum 1 and sum 0 lighting up. Of course, it's a full ripple carry adder. So if I flip the bit 1, not bit 0, of each of these together, of both operand A and operand B together, of course, carry out because we've overflowed. And if I add in carry, of course, sum 0. And of course, this is just it's a full 2-bit ripple carry adder. You could keep expanding upon this ad infinitum to get the number of working bits you want. So if I just flip everything on, all the operands go to 1, then it goes to 1. So yeah, that's pretty much it. This has just been my submission for the DigiKey and Hackaday 2021-2022 555 timer contest. Hope you all enjoyed it. Thanks.